Section 4.4 is called point-slope form and writing linear equations. Of course, the writing linear equations, that's going to involve using point-slope form. So what is point-slope form? Well, it's just another form that linear equations can be in, just like an equation, the way it looks, can be called standard form. That was the last section. And another way equations can look could be called slope-intercept form, and that one, hopefully you know at this point, is when the equation is solved for y. The whole y equals mx plus b thing. So this is another way an equation can look. An example being this right here. This is just maybe a random enough example of a linear equation that the way it looks, the order that it's in, and where everything, all the pieces and parts, we call this point-slope form. And so this is what it looks like in general, okay, where there's no numbers anywhere. It's just all like, variables and placeholder stuff. So it goes y minus y1, or y sub 1, equals m times x minus x1. And now, as you saw in this example here, the x and the y, when it comes right down to it and you're working with an actual equation, x is just going to be x and y is just going to be y. But this x1 and y1, okay, together, that's going to represent any point the line passes through. And m, of course, will be its slope. So that's nice. So just like slope-intercept form, the numbers you see when you're just by looking at an equation in this form, you will know some really useful stuff about the line. So here we go. One type of question you can answer is, if they give you the slope and, some point, right? Like, what's the equation? So this is as basic and just as shallow of a question that you can be asked. Hey, if we just tell you what m is, and if we just tell you a point, which they're basically telling you what x1 and y1 equal. Remember, like if this is a point, that means x1 is the -1 and y1 is the 7, right? What's an equation that we can write? Well, if we use this form, the form that takes these exact types of ingredients, slope and a point, the coordinates from a point, we can have our equation in about 3 seconds. Because what are we going to be plugging in for y1? The 7. What are we going to be plugging in for m? Well, that's going to be our slope, which they say is -3. And what's going to be plugging in for x1? Well, -1, right? And the only reason there's another box here is, I don't know, maybe it's just me, but minus, because again, right, there's a minus built into the formula. It's minus whatever y1 is, and then it's minus whatever x1 is. So if x1 is -1, then a minus is really just plus. So maybe like a good final answer for this equation would be y minus 7 equals -3 times the quantity of x plus 1. Now, let me toss in some extra comments here at the end. Like we're going to call this done, and the reason is it's an equation, and that's all they wanted. Write an equation of the line. Oftentimes, you ready? This is where I'm basically going with this. Oftentimes, they don't just ask for, write an equation. Make it look however you want it to look. Oftentimes, they will ask specifically for slope-intercept form. They'd say, write the slope-intercept form of the equation of a line that has this as its slope and passes through that point. See, if they would have been a little more specific about how they want the final answer to look, then we wouldn't be done, you know. If they wanted slope-intercept form, that basically means that you just want to solve for y. Because again, remember, slope-intercept form is y equals mx plus b. So in this case, we would basically distribute the -3. You know, we'd clear these parentheses by distributing the -3. After that, we would just need to what? Add 7 to both sides, so that we would finish with y being all by itself. And that would be it, really. Not too tough. But considering, again, that they were not being very specific, we can just say, done. That's an equation. Next question. What if they wanted us to graph a line using point-slope form? Well, that's no problem. If what they're giving you in the first place is something that's in point-slope form, well, can't you just look at this and go, hey, if this is in point-slope form, that means that my m, you know, my slope, is 1/2, like right there. That's the m position, you know, right? Y minus y1 equals m times x minus x1. And so in that case, wouldn't x1 be just 2, right? Positive 2. Because again, remember, there's a minus, there's a subtraction built in to the formula, right? There's a minus built in. And so that means your x1 is really just 2. But over here, with this saying plus 5, you know, in a way, you could say that this is minus 5 or minus a -5. So that means that your y1 is actually -5. And so, as far as now drawing this line, you put these together and there's like just some random point that is on your line. So 2 comma -5, x1 and y1 right here. That means our line is going to be passing through that point. And to draw the rest, you know, of our line, we can just use the slope. Knowing the slope is 1/2, meaning up 1, right 2. Remember, rise over run. We would go up 1, positive 1, positive 2. That's to the right. And there's another dot, which is really all we need. But we can go up 1 over 2 again. And in fact, we could do that in the opposite direction, meaning like down and to the left, technically. You know, down and left is the same as going up and right. And so then you would just draw your line. Okay. That's that. So again, not too deep of a question, was it? Just, hey, if they give you an equation in that form, you go, oh, there's my m, there's my x1, there's my y1, and you don't need anything else. Just all right here in front of your eyes to help you graph the line. Grand finale here. What if they give you 2 points? Okay, that is this is like the next step up from this problem. So this is a very common problem or question to be asked, like in a math class, on a keystone exam. You know, hey, if we give you the slope and some point, you know, you give us the equation. Hey, no problem. Those are the perfect ingredients for this formula. But what if what they're giving you is 2 points? All right? What if we want to use this formula, this form, to create a linear equation, but what they're giving you is 2 points? Are they giving you enough to plug in for this formula? Well, yeah. You know, what do we need for this formula? Point slope form. Well, we need a point. Well, as it happens, we have 2 points. So eventually we're going to take our pick. But what else do we need? We need the slope. Do we know the slope right off the bat? No. Can we calculate the slope on our own off to the side? Of course we can. If they give you 2 points, you can figure out slope on your own. This is the formula we've used earlier in the chapter. That was probably not even new to you in this Algebra 1 course. y2, so y2 minus y1 over x2 minus x1. So here's the formula for slope if we have the coordinates of 2 points, 2 ordered pairs. And what does that get us? Well, this is really like 4 plus 2. This is really like 1 plus 1. So I believe this should be 6 over 2, which does that simplify or reduce or just basically divide cleanly? Yeah. So the final slope here, the reduced, simplified final slope, would just be 3. Not 3 over 1, which wouldn't be like wrong, but just 3. So hey, now we know what we're going to plug in for m. We had to kind of figure it out for ourselves off to the side, little side work, little side quest. But now we know what we're going to plug in for m, which of course is 3. But what are we going to plug in for x1 and y1? Let me pause here and hesitate for just a second, not reveal it so quick. What are we going to be plugging in for x1 and y1? Remember, this is just like any point on our line. The coordinates would go in, the x coordinate would go in for x1, and the y coordinate would go in for y1. Can we take our pick? What do you think? You think we could like take our pick of like plugging in that x and that y, or that x with that y? Could we? Well, the answer is yes. We can plug in either pair that we want for x1 and y1. But I bet what a lot of students and teachers do is just use the first one, you know, especially considering we literally just got done calling -1 and -2 our x1 and y1 over in this formula, right? It's x1 right here and y1 right there. So even though, but again, you could have picked this one if you would have wanted. It's not that big of a deal. And you would have, whatever you would have gotten would have been also a good equation. So here we go. That's my point slope form with everything plugged in. Again, without, well, not again, but I want to throw this in. Without my explanations, you know, for the sake of like taking notes and teaching you this, all of these steps go like really fast. You know, once you know your m and your x1 and y1, which doesn't take that long to figure out, plugging these in and getting like a final answer takes seconds to do. You know, so it only took this long because I had to explain every little baby step. So the final answer I'm going to have here is just, well, I like to just say instead of minus a -1, plus 1, instead of minus a -2, plus 2. And once again, same, come on, go away you. But once again, the directions weren't that specific. You know, write an equation. So yeah, this is an equation. I'll stop. If they would have wanted slope-intercept form, you know, y equals mx plus b form, once again, you would just distribute the 3 to clear these parentheses, subtract 2 over, so y's by itself, and you'd have yourself the same equation, basically, but in a different form. It would just look different. Now, what you probably should do here, I recommend that you pause the video and try this one for yourself, just to kind of repeat those steps. So, just to make sure you get it, you know. But, yep, last chance to pause the video before I reveal the answer. Going once, going twice. All right, here we go. So if we want to use that formula, you know, we already have maybe like a 2 and a 5 to go in for x1 and y1 for your point. We need the slope. So we're going to do 4 minus 5 over 8 minus 2. That's the slope formula. And we get negative 1 over 6, which I'm going to actually take another step, technically, to rewrite it like this, like with the negative out in front. It's not super necessary, but I like to emphasize, here and there, that whether your numerator is negative or your denominator is the negative one, really the whole slope, the entire fraction, is negative, meaning it'd be going downhill, right? Whether we're going down 1 and right 6 versus, if the negative was down here, which it's not the way it happened, but you could go up 1 and left 6. It doesn't matter. Either way, the entire fraction is negative. So anyway, whatever. So now I know that we're plugging in negative 1/6 for m. And once again, you have your pick. Theoretically, you could pick the 8 and the 4, but I'm going to pick 2 for x1 and 5 for y1, and once again, write an equation. That's an equation. It's just in point-slope form. If we wanted to do slope-intercept form, we would well, that's not what I wanted to happen. Oh, good Lord. Distribute the negative 1/6, and then add 5 over to the other side, and it would be then in slope-intercept form. But that's it. That's pretty much, at least for now, everything, to get you started with point-slope form. Thank you for following along.